Bonjour, bonjour tout le monde. Très heureux d'être là à SILMO Paris 2025. Voilà, je m'appelle Bernard KRESS et je suis... d'abord, j'ai commencé par la Société internationale d'optique. Donc, je suis le past-président de la Société internationale d'optique et de photonique, le SPIE. C'est la plus grande société d'optique au monde. Et bon, c'est la première fois qu'il y a un Français qui a sa tête. Je suis aussi directeur de recherche à Google, à Mountain View, sur les smart glass. J'ai commencé à Google en 2010-2011 sur un smart glass qui s'appelait Google Glass. Si vous en avez entendu parler, c'était il y a longtemps. Donc je vais parler un peu de ce qui se passe dans le domaine du smart eyewear, mais je vais le faire en anglais pour être inclusif avec tout le monde. Je sais qu'il y a beaucoup de Chinois, d'Allemands et d'Anglais. Donc, I'm going to switch to English, if you don't mind. So, the title of my talk is more specifically display smart glasses. I know that I'm wearing an audio smart glass today, and Estilor is actually showing it off also. I'm going to talk more about display smart glasses. Okay, so we're living in a very exciting time today. And I love to show Google Trends, not because I work at Google, but it really shows the interest of consumers in the names AI glasses and smart glasses. So you can see that over the past 15 years, there was not even a blimp on the radar, even for Google Glass, Microsoft HoloLens, Magic Leap, no real blimps on the radar. Only through the past year, we actually saw a very strong echo with consumer excitement. That's actually what it is, Google Trends, on the terms AI glasses and smart glasses. And you can see that it's actually growing exponentially, which is amazing for this industry today. Of course, it follows the trends of AI. There's other trends that appeared very strongly when Facebook changed its name to Meta, and then that kind of disappeared. That's metaverse, right? So Mark Zuckerberg thought that everybody would actually live in a metaverse about 5 years ago or so. Well, that did not happen, but thankfully he veered to smart glasses, and we're going to talk about this, and this is a success story. So, is the world today ready for an alternative to the smartphone? No, it's not. Not really. But smart glasses can provide user experiences a smartphone can't. And also you might not have to pull it out of your pocket that often, but you'll still have a smart glass. Now, I'm not going to talk about what's happening in 10 years, but what's happening in 2, 3, 4, 5 years, yeah. It's not going to replace the cell phone, but it's going to provide an amazing user experience to the consumer that cannot be shown by smart glasses. So many, including Forbes, think that there's a very strong evolving market for smart glasses, AI glasses, which are mainly audio only, but can also have a display, sometimes monocolor, over about 15 to 20 degree field of view. And then, of course, glasses which look a little bit more like goggles, X-Real, Viture, and so on, which go up to 50 degree field of view and have an immersive part to it. But I'm not calling them smart glasses, I'm calling them smart goggles, and you will see why. Well, today, you can go to the Essilor stand. Today, AI hardware, eyewear reached already a very strong echo with consumers. Ray-Ban Meta glasses are the top selling product in many Ray-Ban stores today. Top selling product, right? And this doesn't come from me, comes from EssilorLuxottica CFO, Chief Financial Officer, Stefano Grassi, on the company's Q3 2024 earnings call. So it's a strong message today for the entire community, eyewear community. But as I said, smart eyewear is not new, right? It's about 1.5 decades old. This is me in 2013. Came back to France, and there was a little article, "The man who sees tomorrow." Well, I didn't see tomorrow because Google Glass didn't work out as expected with the consumer, but worked out very well with enterprise. Enterprise is a niche market. We're not interested in this. We're interested in consumer market. It did not resonate with the consumer. So what did go wrong in the past decade? Well, first mistake, and this is something we didn't know 10 years ago. We know it today. Overselling the futuristic brand. This is a Vogue magazine, had 12 pages on Google Glass in 2013, and showed that there might be a new era for wearable technology with a futuristic flair where everybody would look like, geeks, basically. They had a 12-year spread in the September 2013 issue of Vogue, got the author thinking about fashion and technology and how it began shaping the way we will look and dress in the future. Well, that did not happen, and this was very wrong, and we know today that this was very wrong. Smart glasses need to look like eyewear. Google Glass didn't look like eyewear. Google Glass looked like a gadget that a geek would wear. Mistake number 2, overselling the fashion side. Now, of course, 15 years ago, we already knew that fashion was a great advocate for the acceptance of smart glasses. But that was the wrong fashion, right? That was a catwalk. So we designed Google Glasses so that the color matches the dresses of the mannequin on the catwalk. That was really bad. You don't design smart glasses for a catwalk with Diane von Furstenberg. You design smart glasses for everyone, for 7 billion people, not for 100 women on a catwalk in New York. Very, very wrong. Mistake number 3, overselling on the technology side. And companies like Magic Leap raised $4 billion, not million, $1 billion, and had to, shut down their products, Magic Leap 1 and Magic Leap 2, because they did not resonate with consumer. Not even with prosumer. They resonated well with enterprise, which was a niche market, but not with consumers. And of course, they also did not resonate that much with investors after they burned $4 billion. Mistake number 4, confusing the consumer with acronyms like contextual glasses, smart eyewear, smart glasses, AI goggles, AR, HMD, VR headset, mixed reality headset, video see-through, and XR. The last thing you want to do is to confuse the consumer. The consumer is confused, doesn't know what to buy, just doesn't buy it, right? Enterprise doesn't care. Enterprise knows exactly where the ROI, the return on investment, is, and it doesn't matter if the headsets cost $1,000, $10,000, or even $50,000. It's a drop in the bucket on the return on investment. There's no real return on investment for consumers. So for consumers, the message has to be clear and simple. Today, you have spatial computing headsets, which is the Meta Quest 3, which is the Apple Vision Pro, and the Muhan headset by Google will come out. And then on the other side, you have smart eyewear. There's no AR, VR, MR, XR, forget this. There's only spatial computing headsets and smart glasses. Now they're very different. Spatial computing headsets are all about the digital experience. You switch off the display, you take the headset off, right? Prescription implementation is simple. It's fixed focus stereo because everything is displayed at 2 meters, no matter the stereo disparity. So spatial computing headsets are all about the digital experience, and they are consumer electronic products. Smart eyewear is not a consumer electronic product. It's not. We thought it was 10 years ago with Google Glass, but it turns out it's not. It is an eyewear product. It's an eyewear product like any other eyewear product that you see here, and can only be sold at with an eyewear partner at a brick and mortar eyewear store. Not at Best Buy, not at the Fnac, not at a consumer electronics store. This is very, very different. We learned this the hard way over a decade, but now we know. So smart eyewear is all about, number one, fashion. My wife thinks I look good with my Ray-Ban Metas. It's all about fashion. Number two, it's all about vision correction. Number three, only number three comes a digital functionality, which might actually be used only 5%, 4%, or 3% of the time. But 100% of the time, you have your fashion. 100% of the time, you have your vision correction. So it's an eyewear product. It's not a consumer electronic product. Big revelation at the end of a decade of trying out. And now the largest mistake. Well, what comes first? The chicken or the egg? Or the hardware or the use case? In the Google Glass days, we developed the hardware, and we said, yeah, the developers will find ways to make it useful. So we polished the hardware and didn't polish the use case, which was a big error, even for a company like Google, right? Steve Jobs really knew this very well, and this is 15 years ago already, 20 years ago. You've got to start with the consumer experience and work backwards to the technology. You can't start with the technology and try to figure out where can I sell it. And that's a very strong statement. So you have to find a use case for consumers, and then you have to fine-tune the vector that will provide this use case or this user experience to the consumer. This is called the hardware. So the hardware comes second. The use case comes first. Now, what is the use case? Well, today, finally, we have all 3 stars aligned, and our AR hardware ecosystem, starting with hardware, but actually everything starts from the top, from use case. So today, there's a hardware ecosystem, mainly in Asia, which provides the waveguides, the combiners, the light engines, micro LEDs, laser beam scanners, liquid crystal on silicon, and so on, and all the sensors. So you don't have to reinvent the wheel when you develop smart eyewear. You just buy these subsystems from the companies that make it. Number 2, generic platform. We didn't have this back in the days, 10 years ago. So today we have generic platforms like Android XR, which is an open system by Google. It was unveiled last year. Vision OS, which is a closed system, the closed platform from Apple. You have Horizon OS, which is the system, the platform by Meta, and then Snap OS and many others. And then finally, and everything starts with this, it's the use case, the all-day use case, which is AI-powered use cases, multimodal AI assistant. What is a multimodal AI assistant? Well, see what you see, hear what you hear. Now, you can do this with a phone, but it's very complicated. Something that is on your head is so perfectly suited for multimodal AI agentic or just AI assistant. See what you see, hear what you hear, but if you have a handicap, also see what you hear and hear what you see, depending on your handicap, if you have a visual or audio handicap. But the multimodal AI assistant is so strong, and the smart eyewears are such a perfect hardware vector to implement multimodal AI assistants such as Gemini Astra by Google, Apple Intelligence, Meta AI, and so on. This is a video that shows some of the implementations of a multimodal AI assistant. First, you will see this. This is Gemini Astra. First, you'll see this on smartphone, and then very, very smoothly going to a pair of glasses, and you see the power of multimodal AI assistant when you move from a smartphone to a pair of glasses.
Okay.
There's no sound.
Let's do some tests. When you see something that makes sound. Tell me when you see something that makes sound.
I see a speaker, which makes sound.
What is that part of the speaker called?
That is the tweeter. It produces high-frequency sounds.
Give me a creative alliteration about these.
Creative crayons color cheerfully. They certainly craft colorful creations.
Now we go to a little more serious content.
What does that part of the code do?
This code defines encryption and decryption functions. It seems to use AES-CBC encryption to encode and decode data based on a key and an initialization vector, IV.
See the glasses there?
That's right. What neighborhood do you think I'm in?
It's without GPS.
This appears to be the King's Cross area of London. It is known for its railway station and transportation connections.
But her arms are starting to get very
Do
heavy.
you remember where you saw my glasses?
The assistant.
Yes, I do. Your glasses were on the desk near a red apple.
So for me, 50 years plus, I need this history application. So now you have the glasses on. You don't need your hands anymore. You go to a whiteboard. You're drawing
What can
something.
I add here to make this system faster?
And you ask the AI assistant to
Adding a
help
cache
you.
between the server and database could improve speed.
Imagine the superpower
What does this remind you of?
Schrodinger's cat.
All right, give me a band name for this duo.
Golden Stripes.
Nice. Thanks, Gemini.
So imagine you're on a whiteboard, you're drawing something, and you're forgetting something, and your audience doesn't know that you have an assistant talking to you while drawing, and that assistant tells you, you forgot something here. Oh, you should talk about this, or you should talk about that. You should do this. This is really amazing superpower for the consumer, not for enterprise, not for defense, although defense loves it. Just gave $35 billion to Andy Rill to do this. But this is for everyone.
Hey Gemini, what have I missed in the besties group chat?
Nee and Sarah are discussing meeting later today at Gio's Pizza to celebrate Kelsey's promotion and are wondering if you can make it.
Are there any vegan options there?
Yes, reviews rave about the mushroom penny pasta.
Great, tell the group I'll be there. Oh, and can you send the pic of the blue just to let them know what I'll be wearing tonight?
How's this?
Awesome, send it. Is there a store where I can get a card for Kelsey nearby?
Serendipity Cards is a good choice.
Let's go.
Google also last year and this year showed off sleek smart glasses. I'm not able to show it to you today because it's not out there yet. It's a monocular display, 20 degrees field of view at Google I/O, and Google partnered with Warby Parker, Gentle Monster, to develop this and sell this smart eyewear to the public next year. One amazing use case was the live translate with a display. So here you have Shahram, our VP, on the left side, talking Farsi, he's Persian, and then on the right side, an engineer talking Hindi. And they're talking to each other. They don't understand each other audio, but there's a live translate in English on their glasses, which is amazing. Now, of course, they will work also on Meta glasses and many others, but this is a first demo that we showed this year, which was actually really powerful. Meta Ray-Ban sold about 2 million pairs and plans to sell 10 million a year in the next years. And I call this a success, a real echo with consumers. And of course, the shares of Ray-Ban maker EssilorLuxottica, that's a big booth here, jumped 6% on the reported Meta stake in the AI push. So that stake was about $4 or $5 billion, and Essilor was very happy. And Mark Zuckerberg, I think, did the right thing. 6% in EssilorLuxottica. These are the Orion. These are the glasses that were unveiled last year. This is what I call the art of the possible. It's not really a smart glass for the public. It's really concentrate of technology, and the glasses are worth anywhere between $10,000 and $20,000, plus minus a zero somewhere. So it's just the art of the possible, right? It includes 3 different display engines, micro LEDs, and silicon carbide, amazing waveguide there. Here you can see the LED panels. Now, last week at Connect 2025, Meta unveiled a real consumer product at $799, which is a monocolor. It's not binocular 70 degrees anymore like Orion. It's monocolor 20 degrees. But that's a sweet spot, not for immersive content, but for a multimodal AI assistant. And the waveguide used is a geometric waveguide by Lumos in Israel. And it even corrected the eye glow. The eye glow is something that on the $10,000 pair of glasses was actually horrible. You know, it's light going out the wrong way to the public. And with billions of dollars of investment, well, that technology still produces eye glow, but can go to 70-degree field of view. Now, what Ray-Ban display provides is a display which has no eye glow, but the field of view is smaller. Again, for a consumer technology, a consumer product, you have to have a pair of eyewear. You can't look geeky. You have to look like, they have to look like a regular pair of glasses. You can't have light coming out the wrong direction. So this is why they did the right choice. The waveguide is a mature. EssilorLuxottica already 15 years ago worked with Lumos, but at that time it was really difficult to find applications. The application was AMD, age-related macular degeneration, right? But they started to work with Lumos, and today, you know, Lumos is providing the waveguide for Ray-Ban display. It's very mature. The silicon carbide waveguide that I showed on the Orion pair of glasses with 70-degree field of view is not mature at all. One wafer, silicon carbide wafer, is about $10,000 also. So it will come, but it will take a long time. Mature technology for the display engine also. Remember, in the Orion glasses, this was a micro LED panel. Here it's an LCOS. LCOS is a 30-year-old technology, very mature, which went through incremental improvements in pixel size, power, cost, reflectivity, and so on. But it's a little bigger than a micro LED, just a little bigger, slightly bigger. Now, this is also what Apple did when they introduced the Lisa computer in the early 1980s. It was an amazing technology. It was showing the art of the possible, just like Orion. But then, a year later, or a year and a half later, they produced the Macintosh, the well-polished, the much-loved first personal computer. That's the same thing today. Not as many other companies such as Samsung, Alibaba, Xiaomi, Amazon, and of course Apple, who are working on display smart glasses that might be unveiled next year. On the smart goggle side, these are not smart glasses. A lot of people call these smart glasses. These are bird bath combiners, not waveguide combiners. So they're a little more bulky, but there's a lot of interest in a larger field of view, 50 degrees or 70 degrees, but at low costs. Viture also secured $100 million. We're working with X-Rail on Android XR smart goggle, and there's a lot of excitement there. But why including a display? I don't have a display here. I have AI glasses, audio AI glasses, which actually work very well for me. Why including display in smart glasses when audio might be sufficient? Well, instant point of view, pictures review. So you take a picture, you want to review it. I take a picture here. I cannot review it. Right, I have to take my smartphone out. Now you can review it with a display. Information remnants. So when I ask my AI, what do I need to do right after this conference, right after this talk? Well, the AI might be talking to me, but there's no remnants. The sound comes in, the sound comes out. With a display, you might have 2, 3, 4, maybe even 5 seconds remnants. And if you're busy doing something else, talking to someone else or seeing something, you can still take the time to digest that information. And then the third one is world locking. You can't do world locking with audio, but you can do world locking with display. World locking means your display is locked on the reality. No matter how you move your head in 6 directions, right? Free rotation, free translation, the display does not change. I can move around the display will not change. This is really something magical. It's not just adding display to your reality, it's locking that display to a very specific location in your reality, but for this you have to scan your reality and you have to scan the way your head moves, and that's called 6 degrees of freedom. And that's difficult on a pair of smart glasses. This is okay on a big headset. You might need many cameras and many IMUs, but today it looks like it's possible to have a good 6 with only one camera and only one IMU. Why only one camera? Because you only have 2 sides, 2 temples. One temple is for the camera, one temple is for the display. You don't have more space. You don't want to have a camera right here. You might look like a cyclops, right? So this is possible today. This is why is a large field of view required, while AI info might fit well on a small field of view. This is a student doing his homework, math homework, and this is the little display that should point to that square and say that square area is 4 by 5, right? That might be a 10-year-old or 12-year-old student. But unless you're dead, you move your head around. That's what we do, humans. The head always moves around. So if it's head-locked, so the display is about 5 degrees. If it's head-locked, this is what you see. And it's completely useless. You have the display, it's great, see the display, but it's not world locked. What you need is this. You can move your head around wherever you want, but the display does not change. The display is locked on your reality, and this is the magic of AR display. It's not to have something appearing in front of your eye. This is the very wrong message. The real message for display AI glasses is world-locked information that points to something in your reality and augments your reality. But for this to be efficient, you have to scan your reality. But that will come. So the AR hardware ecosystem is pretty complex, including display engine, waveguide combiner, see-through stack, 6 head tracking, eye tracking, face tracking, gesture sensing, compute, connectivity, batteries, and so on. Let's start with the light engine. There's many different light engines out there. LCOS, micro LED, laser beam scanning, and yeah, looks like Ray-Ban Meta chose LCOS for the first implementation of a consumer electronic for eyewear. Sorry, for the consumer electronic device Orion, they integrated micro LED, which is not a mature technology. But when you go to consumer, the technology needs to be mature. Needs to be mature, at least 20 years maturity for the waveguide and the display engine. So you have different type of micro display panels. I'm not going to enter into detail. It's a little technical here. High temperature polysilicon LCD, which we use in Google Glass. Liquid crystal on silicon, LCOS. These are not emissive. MEMS DLP also, these are not emissive. You have to have a illumination engine. And then the emissive displays, micro OLED and micro LED. Now the big difference between micro OLED is that micro OLED is mature, exists in a long time, but the brightness is quite small. It's only 1,000 nits up to 5,000 or 6,000 nits. Micro LED is a new technology where the pixel goes down to about 4, 3, 2, even 1 micron, and it's not field sequential. It's an RGB display, and can go to millions of nits. Now, of course, why millions of nits? This will burn your eye, right? Now, the waveguide, this magical waveguide, which we're going to talk about it, which carries the display from the display engine up to your eyes and superposes it with your eye, is a very inefficient optical system, about 1% efficient, maybe 0.5% efficient, maybe 1/10% efficient. So you have to have a very, very bright display engine, 1 million nits or 2 million nits to get 1,000 nits at your eye. Now, which one will be used in industry? Is it LCOS? Is it micro LED? Is it laser beam scanning? Well, there's place for everybody depending on the use case, and the use case is listed as an APL, average pixel lit. The number of pixels you need to switch on your display to provide the information that you need when you need it. So between 0 and 5% of the display on, that's typically an AI glass application, such as text, a little bit of text. And then when you go to smart glasses, you can have some kind of images appearing, signs, geolocalization, where you need between 5 and 10 to 15% average pixel lit. And then immersive display goggles, typically Microsoft HoloLens, Magic Leap, where you're in an immersive environment, more specifically in industry, in defense, and then virtual monitor glasses, you can go up to 100%. So if you use an LCOS and a waveguide, it's pretty much the same. You switch on 1 pixel or 1 million pixels, you use the same power. Remember, the power is in the vertical direction. If you use a laser beam scanner, a laser and a MEMS scanner, which sometimes is also called a retinal scanner, well, if you only switch on 1 pixel, you only have the power of 1 pixel, right? And if you switch on all the pixels, you need way more power. So this display architecture is very well suited for info glasses and not really well suited for immersive display goggles or virtual monitor goggles. Same thing with micro LED. Micro LED is an emissive display, whereas an LCOS, it's not. It's a reflective light valve, just like a DLP. Same thing, micro LEDs are very well suited for info glasses and smart glasses, not so much for immersive content and virtual monitors. And then, of course, if you go to bird bath architectures, which are not waveguides, bird bath architectures can implement very efficient smart glasses, but we don't call them smart glasses, we call them smart goggles because they look more like a ski goggle than a smart glass. And that power is very low. And then others, local dimming by companies like Avegant and others that are developing this. We talked about the display engine, let's talk about the combiner optics, the optics that combine that display with the reality. Now, why not, and I showed you the the bird bath architectures, right, which are the most efficient architectures out there. Why? And very low cost. Why? And companies such as X-Rail in China and Viture in China are selling a lot of them, hundreds of thousands of them, right, up to 50 degrees field of view in both eyes. So why doesn't everybody use this? Well, because on the user side, it looks quite bulky. It looks quite thick. It doesn't look like a pair of glasses. It looks like a goggle. It looks like a headset. It looks like something you don't want people to see that you're wearing. You don't want to walk down the street wearing this, but it's perfectly okay wearing this at your desk or in your house for various applications, but not really AI glasses. So hence flat and thin waveguide combiners. On this work on the concept of space folding, right? The waveguide folds the space. Now, waveguide folding is space folding is a flat space in front of your eyes with, of course, push-pull lenses that provides the curvature which we all like in smart glasses. And of course, space folding is also very interesting for other applications such as visiting other galaxies, but we'll talk about this a little later, right? So let's go back to waveguide combiners. They're not new. The first patents were back in the 80s, 90s, and so on. And by the way, the first patent, the second patent is a geometric waveguide. Actually, the third one, the one that is used in the Ray-Ban display today. So you see, it's pretty much public domain. Waveguides can come in 3 different configurations: diffractive, surface relief diffractive waveguides, volume holographic waveguides, and geometric reflective waveguides. Orion used the 70-degree field of view Meta smart glasses use a diffractive combiner, whereas the first consumer product from Ray-Ban, the Ray-Ban display, used a geometric reflective waveguide. This is a classification that I really like, that classifies the waveguide combiners from its the number of plates in front of your eye: 3 plates, 2 plates, 1 plate, and then single plate plastic, single plate curved, from diffractive to holographic to geometric. 1D EPE, what does it mean? One-dimensional exit pupil expansion, because you need to provide a generous eye box, because everybody has a different IPD, interpupillary distance, right? So you have to generate a large IPD. I really like developments here: single plate glass, single plate plastic, and here geometric plastic, flat and curved, with 2-dimensional exit pupil expansion. Meta Orion was diffractive waveguides in silicon carbide, very expensive material. It's not a glass, it's a crystal, but it's transparent. It has an index of refraction of 2.6. 2.6, right? Not 1.7 or 1.8, but you jump to 2.6. It's the art of the possible. Other companies like Digilens are providing other type of structures to implement more regular field of view, such as 20 or 30 degrees field of view. And many other companies are providing diffractive structures, nanostructures, that will be in front of your eyes, protected by two pieces of glass, curved glasses, on the world side and on the eye side. On the eye side, you would actually also have your prescription lens. On the world side and the eye side, if you don't need prescription, you have push-pull lenses. The waveguide always projects the image at infinity, but for a comfortable vision, you don't want to look at infinity. You want to look at about 1.5 meter or 2 meters. So you have a little power in the world side lens and the eye side lens if you don't require prescription correction. This is my conclusion. So the lenses, if you look at I know that all of you look at glasses every day, But now I'm going to ask you to look at them again. And what is the largest real estate on a pair of glasses? It's not the temple. It's not the frame. It's the lenses. And the lenses, up to now, are pretty not very smart, right? Today, the only functionality that are integrated in lenses, which are it's amazing real estate that is on your glasses, much, much larger than the temple or the frames. Well, there's a lot of things, as optical engineers, there's a lot of things that you can do on the lenses. Today, the only thing that we do on the lenses are combiner optics plus bulk optics, prescription lenses. But in the future, this prime real estate that is right in front of your eye, but needs to remain transparent, can be multifunctional. And what are the multifunctionality? Well, optical combiner, bonded prescription lens, tunable liquid crystal lenses to compensate for the vergence accommodation conflict, reverse path waveguide imaging for eye tracking. ET means eye tracking. Eye tracking is very important. Eye tracking is actually a trove of information for any smart glass provider. Eye tracking was an input modality about 10 years ago, so you can look at something in your menu and you can click on it, and that would be eye tracking. But eye tracking is actually a very, very interesting trove of data for companies to target your advertisement. You don't need a display. You don't even need a display. You need to track your eye. You need a camera. The camera knows where you're looking at. The camera knows where you're staring at. Track your pupil, track your heartbeat. The camera knows your emotion when you're looking at something. You don't need to click I like anymore, because your glasses will know yourself better than you know yourself. Will know your emotions better than, faster than you might actually think you know your own emotions. These data today are protected. It's an amazing invasion of privacy. Now we're just at the beginning. What do you think is going to happen in the next years? Do you think that this data will still be protected? Protected today, because you can't scare off the consumer. So eye tracking is an amazing trove of information, and let's see how legal, government level legal will handle this. This is way more complex than the information of your browsing history or of your address or whatever, because these glasses will know yourself, again, better than you know yourself. Embedded LED for in cast plastic, embedded cameras in cast plastic. So these are very small cameras. You don't see them, but these cameras see you. They're right in front of your eye, and these cameras are very, very small. It's like a little speck of sand, but they can look into your eyes right away. Embedded electrochromic in cast glass, switchable and tunable couplers, 5G antennas. 5G antennas can be transparent. Why not put them on the glasses? Heat exchange platform. Silicon carbide is an amazing heat exchange platform. And it's transparent. Push-pull lenses, powered out coupler, display engine to waveguide alignment features, and many others. Binocular display alignment sensors. So today we only have two functionalities on this prime real estate, which is sitting right in front of your eyes. And there are dozens of other functionalities that will be implemented in a transparent way on these glasses. So I would say that if we come back in 10 years, most of these functionalities will be implemented in a pair of glasses, and maybe a non-negligible part of glasses eyewear sold will be smart. They will not all integrate all this information, because again, there are many different sectors in smart glasses, AI glasses, AI hardware, AI smart eyewear, smart glasses, immersion glasses, and so on. So they might only need some of these functionalities. But again, they will all be transparent. You won't see them, but they will see you. They will listen to you. They will see you. They will understand you. They will project the information. But you're not going to see anything, and bystanders looking at you will not see anything. Again, how is this going to happen with invasion of privacy? Well, of course, 20 years ago, everybody said there's no way on Earth a camera can be integrated in a cell phone. I don't think anybody has a cell phone without a camera today. Front and back, and of course, I'm wearing a pair of glasses, has a camera, nobody's really bothered with it. So I think that will happen, and people won't be bothered with it. It will take some time. People will be bothered in the first year, second year. Then they'll find out that these are actually very good use cases. Again, it's a use case. If it's good for you, if you really can live a more productive life, well, you will use it, and you will be okay with all this invasion of privacy, as we saw with the smartphone. And then when you want to go to larger field of view, and maybe not stereo display, a little bit better display techniques. Well, you might go to micro lens arrays instead of a single lens. And here's a little video that shows how this can be integrated. You can actually advance to the little bar there, if you see it. Okay, so this is the standard way to implement imaging through a smart glass. Now imagine that you have an array of micro LEDs, each with a specific color. You overlay an array of micro lenses on it, and this would be typically a micro LED array. And you can combine them on your retina, although they're not combined on the display. The display might actually be sparse and transparent. Now, if you provide off-axis micro lenses, you can even do more stuff. You can actually combine them in ways that are different from their geometrism. Of course, if you can combine colors also. So in direct view, you might have 3 different panels with 3 different colors, but through the micro lens array, off-axis micro lens array, you have this full color display happening, and actually you can do this as a light field, not as stereo display, because stereo display is really what we call the prehistory of augmented reality. You know, it's stereo disparity with a fixed focus, which also is not a very comfortable viewing experience, because you have this back conflict, this vergence accommodation conflict, which happens. Light field will actually allow you to go beyond the vergence accommodation conflict and provide a very good viewing experience. So, if you want to learn more, this is a little advertisement for the conference that we will have in January in San Francisco. It's called SPIE AR, VR, MR, and we will discuss all these technologies, from the light engines to the waveguide combiners to the sensors and so on. So, thank you. I think we might have 5 minutes for questions. Anybody has a question? Yep.
Merci beaucoup pour cette très belle présentation, très riche et vraiment très intéressante. Je voulais vous interroger pour savoir la façon dont le marché mondial va s'approprier ce produit. En 2012, les premières montres connectées se sont vendues à 800 000 exemplaires. En 2025, on en attend 525 millions. En 2030, 760 millions. Donc on voit qu'il a fallu quand même plus de 10 ans. Je pense que peut-être dans l'assistance, tout le monde ne porte pas une montre connectée. Certains, comme mon voisin, n'a même pas de montre. Donc, au bout de combien de temps vous pensez qu'il va y avoir une appropriation? Et j'avais une deuxième question. Est-ce que quand Zuckerberg nous annonce la fin des smartphones au profit des montres, est-ce que c'est pas aussi parce qu'il cherche
au profit des lunettes?
Au profit des lunettes, merci. Est-ce que c'est pas aussi parce qu'il cherche un nouveau marché pour ses actionnaires? Parce que même à 1650 milliards de valorisation, il a besoin aussi de projeter l'avenir. Le métaverse n'a pas marché. On sait effectivement que le marché du smartphone n'est pas un marché de renouvellement. Donc est-ce qu'il n'est pas aussi en train de créer un nouveau marché pour ses actionnaires? Et forcément, chacun derrière des grandes entreprises suit le pas.
Alors, très bonne question. Donc, je vais commencer par la première.
Oui, merci beaucoup.
Donc, analogie avec la montre. C'est bon, vous m'entendez là? Ouais. Donc, la première question, analogie avec la montre. Alors, comme vous avez dit au début, les montres ne se sont pas vendues. Apple, pendant les 2 premières années, n'arrivait pas à vendre les montres connectées. Pourquoi? Parce qu'il n'y avait pas de use case qui résonnait vraiment avec le public. Et c'est les comment on appelle ça, les gym circles qui ont vraiment et le health data qui a vraiment fait décoller les montres. Alors au début, bien sûr, il n'y avait pas vraiment ce use case. C'était un hardware qui était pas mal. C'est comme Google Glass, le hardware était pas mal, mais on ne savait pas trop quoi faire avec.
Pourtant, les premiers en 2013, en tout cas celles de Samsung, pouvaient déjà faire des vidéos de quelques secondes.
Ouais. Vous parlez des... Oui, mais le fait est que pendant les 2 premières années, Apple n'a pas réussi à vendre un nombre considérable de montres. C'est les Gym Circle et le Health Data qui a fait que c'est ce use case qui a vraiment porté les montres. Alors pour les Smart Glass, c'est encore pire. Hein? On a commencé dans les années 2004. Vosix même a commencé dans les années 1990. N'a jamais vendu de Smart Glass au public autre que 5 000 ici, 10 000 là. Et même Google Glass, on en a vendu quelques centaines de milliers. Je ne connais pas le numéro exact, un peu plus d'un demi-million. Mais on n'en a pas vendu au public, hein, aux consommateurs. On en a vendu à l'industrie. Et l'industrie a adoré. Pareil avec HoloLens. Donc j'étais 6 ans à HoloLens, à Microsoft. Le premier casque HoloLens a été dédié aux consommateurs. Aucun retour du consommateur. Par contre, l'industrie a adoré. Et par après, l'armée a adoré aussi. Hein, c'est le contrat de 22 milliards de dollars pour fabriquer les casques IVAS, Integrated Visually Augmented System, mais rien du consommateur. Magic Leap, pareil. Magic Leap 1 était dédié au consommateur. Aucun retour du consommateur. Magic Leap 2 a été dédié entièrement à l'industrie et aussi à l'armée. Alors là, c'est beaucoup plus complexe et beaucoup plus terne que la montre connectée parce que ça a pris 12 ans, 13 ans. Donc 2012 pour Google Glass, on est en 2015. Alors aujourd'hui, encore aujourd'hui, personne ne vend beaucoup de Smart Glass avec display. Hein. Meta vient juste d'annoncer les Ray-Ban Display. Peut-être qu'ils vont en vendre 50 000, peut-être même 100 000, peut-être même un peu plus. Mais les Ray-Ban Audio vont continuer à se vendre à des millions d'exemplaires. Ils en ont vendu déjà 3 millions, je pense. Et ils veulent en vendre 10 millions encore dans les prochaines années. Je pense qu'ils vont le faire. Donc, il y a un marché vraiment très... le marché est là pour les Smart Glass Audio. Hein. avec l'intégration du Multimodal AI Assistant. Mais alors la question est, quid du display? Est-ce qu'il faut un display? Est-ce qu'il ne faut pas de display? Ça, on va le voir dans les prochaines années. Et ça, je n'ai pas de boule de cristal pour vous dire ça. La deuxième question... Pardon? Oui, alors j'en ai parlé un peu aussi, hein, et comme j'ai montré au début, c'est tout commence par le use case. Hein. Donc quelque chose qu'on n'avait pas compris avec Google Glass, on s'est dit bah, tiens, on va développer un hardware qui est bien poli, qui marche bien, et les développeurs vont bien sûr trouver des applications. Ah ben non, ça c'est pas fait. Ça c'est pas fait. Ça c'est fait avec l'industrie à nouveau. Alors l'industrie, bon, bien sûr, ils en ont rien à foutre que les Google Glass soient 500, 1500 $ ou 5000 $. Il leur fallait ça parce que l'industrie, bon, comme Airbus ou Ford ou GM ou beaucoup d'autres industries avaient bien pensé leur ROI, Return on Investment. Mais il fallait développer des applications bien spéciales, bien spécifiques pour chaque industrie, et c'est là qu'il fallait le budget, le plus grand budget. Des centaines de milliers de dollars, $1 million pour un team qui développe des applications. Alors ça, bien sûr, ça n'existe pas pour le consumer. Le consumer veut un use case générique. Et là, pour la première fois depuis 15 ans, eh ben on l'a, et j'en ai parlé, c'est le Multimodal AI Assistant. Et j'en ai parlé beaucoup. Et je pense que c'est ce use case qui va générer le marché. Ouais.
Merci infiniment pour cette présentation fascinante. Comment vous voyez l'évolution du métier d'opticien, d'optométriste avec ce nouveau marché qui, tôt ou tard, permettra de corriger également la réfraction en rentrant dans son smartphone la réfraction et en ayant des verres adaptatifs pour toutes les amétropies. Donc comment vous voyez à 10 ans, à 50 ans, le métier d'opticien?
Alors très bonne question. Et la dernière slide, une des dernières slides que j'ai montrées, hein, c'est l'hybridation de la lentille en incluant des fonctionnalités qui ne sont pas standards dans des lentilles, par exemple un waveguide, un eye tracker, un gesture sensor, une antenne 5G, un heat spreader, et tout ça doit être intégré dans la lentille, hein, en fin de compte. Et je pense que le métier d'opticien, d'ingénieur optique, va évoluer en fonction de l'intégration de ces fonctionnalités dans la lentille. La lentille peut être un peu plus complexe aussi. Aujourd'hui, j'avais parlé des push-pull lenses qui sont de part et d'autre du waveguide. Et puis la lentille de prescription. Alors, la lentille de prescription avec une autre lentille sur le world side. Eh ben, c'est complexe, c'est un peu différent, elle est freeform. La lentille sur le world side, en fait, est générique. Hein. Elle n'est pas placée sur l'IPD de l'utilisateur. La lentille de correction est placée exactement sur l'IPD de l'utilisateur. Donc, il faut une compensation prismatique pour compenser le demi-dioptre ou le dioptre sur la lentille world side. Là, on avait énormément de difficultés à travailler avec des fabricants de lentilles normales, puisque c'est une fonctionnalité non pas asphérique, mais freeform, qui a dû être intégrée et qui n'est pas standard. Et déjà là, on a eu beaucoup de problèmes, mais nos partenaires sont arrivés à générer ces lentilles freeform de façon assez... Enfin, ça a pris du temps. Ça a pris du temps. Alors imaginez les autres étapes, inclure des caméras, inclure des senseurs, inclure beaucoup d'autres fonctionnalités. Ben, y a beaucoup de travail. Hein. Pendant 300 ans, 400 ans, il n'y avait que la vision. Hein. Et là, maintenant, il y a au lieu d'avoir une fonctionnalité, il y en a 12 qu'il faut intégrer dans ces lentilles. Et là, c'est fabuleux. Hein, parlant de ce qui va se passer dans les prochaines années. Une autre question hein? Si vous avez des questions, je vais rester un peu aux alentours, mais il y a un autre speaker qui va passer là maintenant. Merci beaucoup. Merci.